In this video, I am going to solve this problem where 9 students they travel from Rajshahi to Borishal by 2 cars. One of these cars can hold at most 7 people and the other one can hold at most 4 people. How many different ways can these 9 students travel in these 2 different cars? That's what the problem is. To solve this problem, we kind of create a small table. The car 1, let's say that one can hold up to 7 people, okay, and car 2, it can hold up to 4 people. Now let's find out how many different ways these 9 students can travel. So let's start off with the scenario where 7 students travel in car 1. So 7 of them are going to travel in car 1. In that case, the remaining 2 are going to travel in car 2. Okay, so that's one scenario. In the next case, let's say 6 of them travel in the first car. In that case, 3 of them are going to travel in the second car. And in the third case, 5 of them travel in the first car, and then 4 of them can travel in the second car. Now our table is gonna end here. Why? Let's say we have 4 people traveling in the first car. Okay, so 4 people traveling in the first car. In that case, 5 people have to travel in the second car, but the second car can only hold 4 people, so it's not possible. So these are the only possible ways these 9 students can travel from Rajshahi to Borishal in these 2 different cars, with the restriction that the first car has 7 spaces and the second car has 4 spaces. Now let's go ahead and consider these scenarios one by one. But before we do so, let me clarify something. Let's say in the first case, 7 students travel in the first car and 2 students travel in the second. Note that the permutation is not important here, but rather combination, because the order in which these students, 7 students, travel in the first car doesn't really matter. Okay, it's just 7 students that are traveling in the car. So that's an important fact you have to understand. Once again, is the order in which the students travel in these cars does not matter. Okay, so let's say student 1 we denote by S1 and all the way up to student 7 S7. Okay, the order in which they travel is not important. So the order in which they sit in the car is not important. The same for car 2. So we are going to have to think about combination because the order doesn't matter. Now, how many ways can this happen? The first scenario. Look, we have 9 students. Of those 9 students, we are going to take 7 of them. So how many different ways can we do so where the order does not matter? It's going to be 9, C, 7. Okay. Then the remaining 2. So if we have taken 7 students away from 9, there are 2 left, right? So in that case, we don't have a choice. We are going to take 2, C, 2. But you have to keep in mind, these are kind of like 2 different events. That this is event 1 and this is event 2. This one can happen in this many ways, 9C, 7 ways. And the second one can happen 2C, 2 different ways. Together, they can happen 9C, 7 times 2C, 2 different ways. Like for instance, let me give you a simple example. You can dress in 3 different ways, okay? Your friend can dress in 4 different ways. Together, you can dress in 3 times 4 is equal to 12 different ways. So this is just a simple example. So once again, you can dress in 3 different ways. Your friend can dress in 4 different ways, 2 different events. Together, you can dress 3 times 4 or 12 different ways. The exact same logic here. Now that's for just the first combination. Now we are going to have to do the exact same calculation for the second combination. So, and we are going to have to add it together. So it's going to be 9C6 times 3C3. And now for the third one is going to be 9C5 times 4C4. Now all we have to do is simplify this and then add the numbers. Now basically I simplify these expressions and just use the formula for combination. Just to remind you, what is the formula for combination? It is NCR is equal to n factorial divided by r factorial times n minus r factorial. That's the combination formula, and by applying this formula I get from this, I get this, from this I get this, and consecutively I get for this and this, this and this. Now I simplify it, I get this. So it's pretty straightforward going from this step to this step. So look, one example, 9 factorial divided by 6 factorial. Okay, then 9 factorial divided by 6 factorial, 9 minus 6 is 3 factorial. So this is just one example. And then 3 factorial divided by 3 factorial right here, but 3 minus 3 factorial is 0 factorial. And we do it for each single term. Now couple of things to remember here. Remember, 0 factorial is always 1. Okay, that's the definition. That's how we define 0 factorial. And then we just straightforward do calculation. One more thing to remember is this 9 factorial. For instance, I can write it as 9 times 8 times 7 factorial. Why did I do that? Look, in the denominator I have a 7 factorial. I did expand it in a way so that this 7 factorial and 7 factorial cancel out. And similarly I did it for each of these terms. Okay, and if I do all these calculations, I get 36 plus 84 plus 126. That, by the way, gives me 246. So that means there are 246 different ways this traveling can happen by using these two cars, where the first car can hold at most 7 and the second car can hold at most 4, and the number of students who travel in these two cars is 9. Okay, so that's what it is. Now let me kind of summarize what I did again. There are 9 students that are traveling, 9 students traveling in 2 different cars. One car can hold at most 7 people, the other can hold at most 4. How many different ways can they travel? If the first car holds 7, the other will hold 2. If the first car holds 6, the other will hold 3. If the first car is used by 5 students, then 4 would be going to the second car. And those are the different ways it can happen. Now only consider the first one. In that case, out of 9 we have to pick 7 students where order doesn't matter, so it will be a combination. So 9C7. Once you pick 7, there are 2 choices, 2 students left, and you have to pick both of them. So that's why I have 2C2. And similarly for the second one, I pick 6 students, 9C6, and the remaining 3C3. And for the third one, I take 5 students. For the first car, it's going to be 9C5, and the remaining 4 goes into the second. And by using the combination formula, I simplify it, and then I come up with these numbers. If you are not clear on these calculations, it would be a good idea to pause the video and then look at these calculations and make sure that you understand and you know how to do them on your own. I hope that this discussion was helpful. Thank you very much.